Alrighty, hello everyone. My name is Kit, and today I'll be going over my solution for the Advent of Coding Challenge 2021, day 22. So let's jump ahead into the presentation here. So the general idea for my algorithm was like this. So first we add the on-off cube from our processing input. And then afterwards, we retract the intersections for all of the previous cubes. And then we repeat steps 1 and 2 for all of the input cubes. Then after we're done, we just sum up all of the volumes. So if it's an on cube, then that means it's going to be a positive volume. If it's an off cube, it's going to be a negative volume. So to give you an idea of what I'm talking about when I say retract intersections, let's walk through a few examples. But instead of the two-dimensional case or the three-dimensional case, let's just think about it in terms of one dimension. All right. So say we have a line like this. So our first input line is like this, like so. Then here's our second input line, which is like this. So the problem here is that if we just straight up add the length of 2 to 1, then what we do is we end up adding this part twice. So we can't do that because this is when it's on is already on. So what we have to do is subtract that little space that it intersects. So this is what we call a retraction. So we add basically another segment here, which is just basically going to be like an off cube to subtract the segment that intersects with the previous segment. So this is what we call a retraction. Okay. And then in the end, what we end up with is a line like this. So this is this gray line. This undo, or this gray line is the resulting line. And I'll just erase this. Okay, so let's just go through a few more examples of like how this would look like in the one-dimensional case. And then afterwards, I'll just explain my code. It's going to look very similar to this idea here. Okay, so here we have two lines that were, oh, actually this is just a continuation of this first example here. So say we add this third line here. So what do we do? Well, we iterate through all subsequent cubes that we've added or that we've processed so far. And then we retract those lines as well. So the first one that we look at is this one here. All right, so this is subtracting. But since this is going to be an on cube, we want to add that part back because this line here basically subtracts this section here, and we don't want that. We want to add it back, so that's what we do. We add another line back. So this is the retraction. This is also a retraction for the case when we're processing through like an off line. Okay, so we already looked at this line. Next, we have to look at this line. So, for line number 2 here, you see that we add another on line, and if we have an on line and an on line overlapping, then what happens is that we double count this section here, and we don't want to double count it, so we have to subtract it. So this is what we do over here. We subtract it. Okay, finally, we look at this last line here, which is number 1. So this part right here. And then notice that if we add this section onto this section, what we end up doing is double counting, and we don't want to double count, so we retract that, we subtract it. So we retract it right here. So in the end, what happens? Well, look here, because this is really cool. We end up subtracting both of these, so like these two cancel each other out. This part here cancels out with this part, with like this whole entire section here. And we already went through the case for line number 2. So you see here that these two cancel each other out. So what we're left with is this endpoint right here, which is exactly what we want. So we just have the line from number 1 and this small snippet of line here, right here. Right, and this is our resulting line. So we end up not overcounting anything. So let's go through another example. So here we have number 1 is this line, and then number 2 is this line right here. So since we already subtracted from number 1, that makes sense because we want 2 separate sections. So there's no retraction that happens when we add number 2. And let's look at number 3. So when we add number 3, when we look back, we see that there's an off line. And if we have too many like negatives, then we end up double counting the negatives as well. And we don't want to do that, so we add back a positive line to retract that negative. So this here is the retraction. So what ends up happening? Well, this line, and this line, they both cancel each other out. This line crops up this section here. So what we end up getting is the length of this section and then this section. Pretty cool, which is exactly what we want. Alright, let's go through another example. So number 3, when we add line 2 here, nothing happens because this is exactly what we want to cut off this section here. For number 3 here, we follow the same algorithm, so we go through all the subsequent lines. So let's look at number 2. So for number 2, it intersects at this point right here. Alright, so since this line is subtracting our section here, we want to retract that subtraction, so we add another line here. And then if we look at compare number 3 to number 1, you see here that if we add this line, then we end up double counting this section. So since we don't want to double count it, we add a subtract line here. So what happens in the end? Well, number 2, this line and this line cancel each other's out. This and this cancel each other out. So we just end up with number 1 by itself yet again. Pretty cool. Okay, last example, number 4. So this is just a longer one. So we start with number 1, looks good. We add in number 2. So when we add in number 2, we have to look at all the subsequent lines and see if there's any intersection. So we see here that it intersects here. And you see that we end up double counting, so we have to subtract that double count. Alright, and then that looks pretty good. Okay, so when we add line number 3 here, we have to look back at all these previous lines as well. So let's look at this one. So this is subtracting our section here, and we don't want that to happen, so we add that section back. So we add that section back right here. And then let's see, so number 3 intersects with number 2. This is double counting, and since it's double counting, we have to subtract it. And then finally, for number 1, you see that we end up double counting the section, so we have to subtract it. Alright, so then next, let's look at this is the 4th line that is from the processed input. So for this line right here, you see that it intersects at this part with this section here. So this is subtracting, and we don't want that because we want to add this section here. So we add back that section. And then when we look here, subtracting, so we have to add. Then for this one, it's a positive line, and this is double counting, so we have to subtract. And over here for this one, this is a positive line, double counting, so we have to subtract. And for this line here is subtracting, which cancels out our line, which is not what we want, so we have to add it back. Then number 4 intersects with number 2 at this section right here. We don't want to double count, so we subtract. Then finally, look at number 1 here, it intersects at this section right here. It's going to double count, so we have to subtract. And watch this. This is super cool. So what ends up happening is that these here cancel each other out. This cancels each other out. We cancel this section. So like this, I'm not sure how to draw it, how best to draw it, but it's like, so like this section we cancel out, which leaves only like this section right here. And then if we look back onto these sections, if we follow like the retraction steps from before, then we should have already like taken care of these scenarios. So what we end up having is basically like the line from here to here. So we end up having this line and then this line right here, which is what we want. So the resulting line looks like that. Looks like let me see. Try to draw it here. Oh, it goes right here, like that. Alrighty, so yeah, our algorithm makes sense. If you want, I could also go back and talk about these. So like this one here cancels out with that. This cancels out with this. This part cancels out. So then we are left with this section here. So then we have this section, plus this section, plus this section right here, which is what we get, this gray line right here. Alright, if you want to prove yourself further with this algorithm, just like walk through some of these examples here or create your own. So what I ended up doing was programming this solution, but for the 3D case, I'll go ahead and walk through my code. Not that one, it's this one right here. Okay, so this was for part number 2. So here you see that I just processed the inputs. I store it into this data structure called a cube, which has an action, which is either like on or off, and then it has the different X, Y, and Z ranges. Then here we have our list of output cubes. This is just like a linked list, and this basically stores all of these different segments as we continue to follow the algorithm. Okay, so here we are iterating through all of the process inputs. We iterate back. So we look at all the output cubes that we process and we see if there's any intersections. Then we iterate through all of these intersections, and then there are some specific logic that we need to do, like before from how I explained it. So if the intersection and the input is on and on, then we have to retract it. So we have to add an off section for that cube. If it's on and off, then we want to re-add it. And if it's off and on, then we want to add an off section to retract the on section. If it's off and off, then we don't want to double count the negative, so we have to add the on section. And then afterwards, all it is just summing up the different cubes. So if it's on, it's going to be a positive volume. If it's off, it's going to be a negative volume. So if I go ahead and run it, I'll just let you see how long it takes. It's probably going to take a while because I am recording with OBS and my computer is quite slow. Yes, taking a while. But yeah, if you are interested in running the solution yourself, you can clone the repository and check it out. Thanks for watching and have a good one.